What transforms a forgotten aircraft into a legend? The answer lies not in blueprints or engine specifications, but in the hands of a single pilot who refused to accept what everyone else already knew as truth. Throughout military aviation history, certain aircraft entered service with such underwhelming reputations that veteran pilots would rather walk into combat than climb into their cockpits. The skies over Berlin in late 1943 saw one such machine, a fighter that experienced aviators dismissed, that ground crews mocked, and that strategic planners nearly scrapped before it ever proved its worth. This is the story of how conventional wisdom collided with extraordinary determination, how a rookie pilot's refusal to surrender changed the calculus of aerial warfare over Nazi Germany, and how a despised aircraft became the unlikely instrument of tactical revolution. Before we examine the machine itself, we must understand the context that made its rejection almost inevitable and its redemption almost miraculous. The air war over Europe had reached a critical juncture where bomber losses threatened the entire strategic doctrine of daylight precision bombing, where Luftwaffe fighters ruled their home skies with brutal efficiency, and where Allied planners desperately sought solutions that existing aircraft simply could not provide. But sometimes the solution already exists, ignored and gathering dust, waiting for someone brave enough or foolish enough to see what others cannot. This is that story, a narrative of redemption written in contrails across German skies, where a single pilot's trust in an untested aircraft would cascade into tactical transformations that altered the aerial campaign's trajectory. The plane was real, the pilot was real, and the consequences of their partnership rewrote assumptions that had governed fighter doctrine since the beginning of the war. The despised aircraft carried the designation P-47 Thunderbolt, though pilots knew it by cruder names that reflected their contempt rather than admiration. The rookie pilot answered to Second Lieutenant Robert S. Johnson, a name that would eventually appear in histories of aerial warfare, but in early 1943 meant nothing to anyone beyond his immediate squadron. Their convergence in England's damp airfields represented the kind of accident that changes history, not through grand design but through circumstance, necessity, and the peculiar alchemy that sometimes occurs when the right person encounters the right tool at exactly the right moment. The year 1943 represented a crossroads for Allied air operations over occupied Europe. American strategic bombing doctrine had committed fully to daylight precision attacks, a philosophy born from interwar theories that heavy bombers could operate independently without fighter escort. The reality proved devastatingly different. Between July and October 1943, the 8th Air Force suffered catastrophic losses during missions deep into German territory. The second Schweinfurt raid in October alone cost 60 bombers shot down and another 17 damaged beyond repair, a loss rate of nearly 26% that proved mathematically unsustainable. Into this crisis environment arrived the Republic P-47 Thunderbolt, a massive fighter that weighed more than twice as much as the nimble fighter's pilots had grown accustomed to flying. The P-47 emerged from Republic Aviation's engineering philosophy that prioritized pilot protection and firepower over traditional fighter agility. Its radial engine displaced 2,800 cubic inches, its airframe could absorb punishment that would shred lighter fighters, and its .850 caliber machine guns delivered more destruction per trigger pull than any fighter then operational. Yet none of these advantages impressed the pilots who first encountered it. Veterans transferred from P-38 Lightnings and P-51 Mustangs looked at the Thunderbolt with undisguised contempt. They called it the Jug, initially as criticism, short for juggernaut, a name that emphasized its ponderous bulk rather than any admirable quality. In briefing rooms across England, experienced fighter pilots openly questioned whether the aircraft could even keep pace with the bombers it was meant to protect, let alone engage the agile Messerschmitt Bf-109s and Focke-Wulf FW-190s that German pilots flew with lethal proficiency. The P-47's reputation suffered from timing as much as characteristics. It entered service during a period when American fighter pilots had developed doctrine around lighter, more maneuverable aircraft. The prevailing wisdom held that dogfighting required rapid turns, quick acceleration, and nimble handling, precisely the attributes the massive Thunderbolt seemed to lack. Early combat reports did nothing to dispel these prejudices. Pilots who attempted to dogfight German fighters at medium and low altitudes found themselves outmaneuvered and occasionally shot down, confirming the aircraft's critics in their assessment that Republic had built a failure. Ground crews contributed their own complaints. The P-47 required more maintenance than lighter fighters. Its complex turbocharger system demanded constant attention, and its sheer size made it cumbersome to service in the cramped conditions of English airfields. Mechanics who had worked on sleek P-51s found the Thunderbolt's bulk frustrating, its radial engine difficult to access, and its systems unnecessarily complicated. This ground-level frustration filtered upward, reinforcing command-level skepticism about whether the aircraft justified its logistical burden. Strategic planners faced their own dilemma. The P-47's initial variants lacked the range to escort bombers deep into Germany, the very mission for which long-range fighter escort had become desperately necessary. Even with external fuel tanks, early Thunderbolts could barely reach the German border before turning back, leaving bombers to face the worst of the Luftwaffe defenses alone. This limitation seemed to confirm that the aircraft was fundamentally unsuited to the strategic requirements of the air campaign, an expensive mistake that consumed resources better spent on other platforms. The technological context surrounding the Thunderbolt's development revealed ambitions that exceeded execution in crucial respects. Republic Aviation had designed the aircraft around the Pratt & Whitney R2800 double WASP engine, a power plant that represented the cutting edge of radial engine technology. The turbocharger system that allowed the engine to maintain power at high altitude constituted an engineering marvel, but also a maintenance nightmare that required constant adjustment and frequent replacement of components that wore rapidly under combat conditions. Ground crews in England struggled with turbocharger failures that grounded aircraft for days while replacement parts arrived from the United States. The aircraft's weight distribution created handling characteristics that violated every expectation fighter pilots brought from previous aircraft. The massive engine's weight concentrated forward of the cockpit, creating inertia that made rapid direction changes feel sluggish compared to lighter fighters. The broad wings provided excellent high-altitude performance, but generated drag at lower altitudes that reduced acceleration and top speed. The wide landing gear track made ground handling straightforward, but added weight that contributed to the aircraft's ponderous reputation. Every design choice reflected trade-offs that optimized certain characteristics while sacrificing others, but pilots accustomed to well-rounded fighters found these trade-offs unacceptable. Yet amid this chorus of criticism, one rookie pilot saw something different. Second Lieutenant Robert S. Johnson arrived in England in early 1943, assigned to the 56th Fighter Group, one of the first units to receive the P-47. Unlike veterans who judged the Thunderbolt against their experience in other aircraft, Johnson came to the cockpit without preconceptions, without the comparative framework that led experienced pilots to dismiss the massive fighter. Where others saw limitations, he recognized potential. Where veterans complained about the aircraft's weight, he understood mass could provide advantages in specific tactical scenarios. Johnson's background provided no obvious indication he would become the pilot to vindicate the P-47. Born in Lawton, Oklahoma in 1920, he grew up during the Depression in modest circumstances that offered little suggestion of future aviation glory. He had not grown up around aircraft, had not demonstrated childhood obsession with flight, and brought no family aviation tradition to his military service. He simply possessed the determination to master whatever machine the Army Air Forces assigned him, combined with an analytical mindset that sought to understand rather than judge. His educational background reflected the era's limitations. High school graduate at a time when college remained accessible only to economic elite, vocational training that emphasized practical skills over theoretical knowledge, work experience in manual labor that built physical resilience, but provided no intellectual preparation for the complexities of modern warfare. Yet these apparent disadvantages created unexpected strengths. Johnson approached problems without preconceptions about proper solutions, analyzed situations without theoretical frameworks that might constrain thinking, and persisted through difficulties without expecting success to come easily. The cultural context of American fighter aviation in 1943 emphasized individual achievement and aggressive tactics that reflected national character more than tactical optimization. American pilots entering combat brought expectations shaped by Hollywood representations of World War I aces, by newspaper accounts that celebrated personal courage over systematic execution, by training that emphasized offensive spirit over careful analysis. This cultural background created pilots who excelled at aggressive attacks, but sometimes struggled with disciplined tactical execution that required subordinating individual initiative to coordinated group action. Johnson's personality diverged from this cultural template in subtle but significant ways. He possessed aggressive instincts, but tempered them with analytical restraint that sought to understand before acting. He valued personal achievement, but recognized that survival preceded glory in importance. He respected tradition, but did not consider it immune from questioning when evidence suggested alternatives. These characteristics made him unusual among fighter pilots, but perfectly suited to recognizing that the P-47 demanded different approaches than conventional doctrine prescribed. This convergence, a despised aircraft and an inexperienced pilot without prejudice, created the conditions for tactical innovation. But the transformation from rejection to redemption required more than just willingness. It demanded combat experience that would forge theory into practice, encounters that would test assumptions, and ultimately a mission over Berlin that would demonstrate to the entire 8th Air Force what a single pilot had already discovered through study and instinct. Robert Johnson's path to fighter aviation began not with childhood dreams of aerial combat, but with the practical realities of wartime mobilization. After Pearl Harbor, young men across America flooded recruiting stations, driven by patriotic duty and personal ambition in roughly equal measure. Johnson enlisted in the Army Air Forces in November 1941, entering a training pipeline that would transform civilians into combat pilots within months, a compressed timeline that sacrificed nuance for necessity. His flight training progressed through the standard sequence: primary training in light aircraft, where students learned basic aeronautics, basic training in more powerful planes that introduced military-specific skills, and finally, advanced training in actual combat types. Johnson demonstrated competence rather than brilliance during this progression, earning satisfactory marks without distinguishing himself as a natural aviator. His instructors noted methodical learning style and thorough approach to mastering aircraft systems, qualities less glamorous than natural flying ability, but often more valuable in combat conditions where survival depended on technical understanding rather than instinctive flair. The training environment itself reflected America's industrial approach to warfare. Airfields across the Southwest operated around the clock, churning out pilots whose quality varied wildly, but whose quantity would eventually overwhelm Axis air forces through sheer numbers. Young men who had never traveled beyond their home counties suddenly found themselves in Texas or Arizona, living in hastily constructed barracks, flying aircraft that represented the cutting edge of aviation technology. The pace left little time for reflection or doubt. Students who failed washed out quickly, reassigned to other duties without ceremony. Those who succeeded moved forward to operational training and eventual deployment overseas. The primary training phase introduced Johnson to powered flight in aircraft, like the Stearman PT-17 biplane, a forgiving trainer that allowed students to make mistakes without immediately fatal consequences. He learned fundamental aeronautics through direct experience: how airspeed and angle of attack determined lift, how rudder and aileron inputs coordinated in turns, how engine power and aircraft weight affected climb performance. These basics formed foundation for everything that followed, establishing intuitive understanding of flight mechanics that would prove essential when combat demanded split-second decisions without time for conscious analysis. Basic training transitioned students to more powerful aircraft like the BT-13 Valiant, introducing characteristics that foreshadowed combat types. Higher speeds required faster reactions, greater power demanded more careful engine management, and formation flying introduced the challenge of maintaining precise positions relative to other aircraft while simultaneously controlling one's own machine. Johnson adapted to these increased demands through the same methodical approach that had characterized his primary training: systematic practice, careful attention to instructor feedback, progressive refinement of skills through repetition. Advanced training placed students in actual combat aircraft, typically AT-6 Texans, that approximated fighter performance without the complexity or danger of operational types. Here Johnson encountered gunnery training that would determine whether he qualified as fighter pilot or received reassignment to bombers or transports. Aerial gunnery demanded entirely different skills than basic flying. tracking moving targets while one's own aircraft maneuvered, managing deflection angles that accounted for relative motion between attacker and target, timing bursts to place rounds where the target would be rather than where it currently appeared. Johnson excelled at gunnery through the same analytical approach that characterized his flying. He studied ballistics, understanding how bullet trajectories curved through air and how that curvature changed with range and altitude. He practiced tracking techniques systematically, developing smooth follow-through that kept gunsight pipper on target throughout firing passes. He learned to estimate range accurately, recognizing visual cues that indicated when targets entered effective firing distance. These skills would later prove essential to his combat success, but during training, they simply represented requirements to be mastered like any other. Johnson received his wings and commission in July 1942, then entered operational training in the P-47 at Bridgeport, Connecticut, under the supervision of the 56th Fighter Group. This assignment proved fortuitous. The 56th would become the highest-scoring P-47 unit in the European theater, but in late 1942, it was simply another fighter group working through the challenges of mastering a new and controversial aircraft. Colonel Hubert Zemke commanded the group, a hard-driving leader who believed in the Thunderbolt's potential despite widespread skepticism. Zemke's confidence in the aircraft would prove essential to developing tactics that maximized its strengths rather than lamenting its limitations. During operational training, Johnson began to understand the P-47's fundamental nature. The aircraft refused to be flown like lighter fighters. Pilots who tried to maneuver it through tight turns at medium altitude found themselves disappointed and occasionally frightened as the massive fighter bled energy. But Johnson noticed something others overlooked. At high altitude, where the P-47's turbo-supercharged engine maintained power, while other fighters gasped for air, the Thunderbolt became a different machine. Above 25,000 feet, it accelerated surprisingly well, maintained energy through gentle maneuvers, and possessed dive characteristics that allowed it to outrun virtually any opponent. This high-altitude advantage corresponded precisely with the operational reality of bomber escort. American B-17s and B-24s attacked targets at altitudes between 20,000 and 30,000 feet, exactly where the P-47 performed best. Johnson began to theorize that the aircraft had been optimized for the wrong mission profile in early combat encounters. Pilots attempting to dogfight at medium altitude were playing to the P-47's weaknesses rather than its strengths. Instead, the Thunderbolt demanded different tactics: maintain altitude advantage, use superior speed in diving attacks, refuse turning engagements, and rely on the aircraft's legendary durability when mistakes occurred. The physics underlying these tactical principles became clearer through Johnson's systematic study. At high altitude, air density decreased significantly compared to sea level, reducing drag but also reducing available oxygen for engines without forced induction. The P-47's turbocharger compressed thin, high-altitude air before feeding it to the engine, maintaining sea-level power output at altitudes where normally aspirated engines produced barely half their rated horsepower. This power advantage translated directly into superior performance in the thin air where bombers operated and where combat increasingly occurred. Weight, which seemed such a disadvantage in turning fights, actually benefited the P-47 in diving attacks. Newton's laws dictated that heavier objects accelerated more slowly, but also decelerated more slowly once moving. The Thunderbolt's mass meant that once it achieved high speed in a dive, it maintained that speed more effectively than lighter fighters that experienced greater deceleration from air resistance relative to their mass. This characteristic allowed P-47 pilots to dive away from trouble at speeds lighter fighters could not match, providing escape option that fighters optimized for turning performance lacked. Structural strength represented another aspect where the P-47's apparent excess translated into tactical advantage. Republic engineers had designed the airframe to withstand forces that would tear apart lighter fighters, anticipating that combat damage and violent maneuvers would impose stresses exceeding peacetime safety margins. This overbuilding meant P-47 pilots could execute high-speed dives and pullouts without fear of structural failure, while pilots in lighter fighters had to moderate their maneuvers to avoid exceeding airframe limits. The psychological freedom this provided proved as valuable as the physical capability. Pilots who trusted their aircraft's strength flew more aggressively than pilots constantly monitoring for signs of structural distress. Johnson absorbed these lessons during months of operational training that transformed theoretical understanding into practical skill. He practiced diving attacks until they became automatic, learned to judge angles and closure rates instinctively, developed feel for how much lead to apply when firing at targets in various maneuver states. He studied German fighter tactics from intelligence briefings, understanding how Luftwaffe pilots typically attacked bombers and how they responded when American fighters intervened. He learned radio procedures, navigation techniques, emergency procedures for various failures, all the mundane but essential skills that separated trained pilots from combat-effective aviators. The 56th Fighter Group deployed to England in January 1943, arriving at RAF Horsham St. Faith before moving to their operational base at Halesworth. The English winter greeted them with characteristic bleakness, fog, rain, mud and cold that seeped into barracks and aircraft alike. Ground crews struggled to keep the P-47s operational, in conditions far harsher than their American training bases. Pilots dealt with the psychological adjustment from training to combat status, knowing that their next flights would involve live ammunition and real enemies rather than simulated engagements and friendly competition. The transition from training to combat operations involved more than just flying against actual enemies. It required adapting to operational realities that training could simulate but never fully replicate. Weather became enemy as dangerous as German fighters. Dense fog that obscured airfields during landing, icing conditions that threatened engine failure, storms that scattered formations and killed through spatial disorientation rather than enemy action. Mechanical failures acquired lethal significance when they occurred over enemy territory rather than friendly training bases. Navigation errors that meant embarrassment during training could mean death or captivity during combat operations. Johnson's first combat mission occurred on April 13, 1943, an escort mission for bombers attacking targets in France. He experienced the disorienting complexity of combat flying for the first time, maintaining formation while scanning for enemy fighters, managing fuel consumption, monitoring radio traffic amid constant chatter and occasional panic. The mission encountered no enemy opposition, allowing Johnson and other rookies their first taste of combat, flying without the added stress of actual combat. But this grace period ended quickly. Subsequent missions brought contact with Luftwaffe fighters whose pilots possessed years of combat experience and aircraft, optimized for the medium-altitude fighting that seemed to give them every advantage. Early combat reports from P-47 units validated the critics' skepticism. German fighters consistently outmaneuvered Thunderbolts in turning fights. American pilots returned with damage that raised questions about the aircraft's survivability, and loss rates suggested the P-47 might not be viable for sustained operations. Within the 56th Fighter Group, some pilots privately requested transfers to P-51 units, preferring the Mustang's nimble handling to the Thunderbolt's bruising approach. Johnson heard these complaints, but remained unconvinced that the aircraft itself was at fault. He studied after-action reports obsessively, looking for patterns in successful engagements versus unsuccessful ones. What he discovered confirmed his training observations. P-47 pilots who tried to turn with German fighters usually lost or at best fought to a draw. But pilots who maintained altitude, attacked in diving passes, and refused to be drawn into turning fights often succeeded. The aircraft wanted to fight vertically rather than horizontally, using gravity and mass as weapons rather than trying to outturn lighter opponents. This analytical approach distinguished Johnson from many contemporaries who flew by instinct and courage rather than systematic study. He began experimenting with tactics during training flights, practicing diving attacks that maximized the P-47's speed advantage, learning how to manage energy in the aircraft's preferred high-altitude environment, understanding how to use the Thunderbolt's weight to advantage in specific maneuvers. Other pilots noticed his unconventional approach, some with interest, others with skepticism that a rookie presumed to understand the aircraft better than veterans. The psychological dimension of this learning process deserves recognition. Johnson faced constant pressure to conform to established doctrine, to defer to veterans' experience, to accept that his alternative theories represented naive misunderstanding rather than legitimate insight. Every mission where P-47 pilots suffered losses reinforced the narrative that the aircraft was fundamentally flawed. Every debriefing where veterans recounted being outmaneuvered by German fighters validated conventional wisdom. that the Thunderbolt could not compete. Yet Johnson persisted in his analysis, trusting evidence from after-action reports more than opinions from tradition. This persistence reflected not arrogance but genuine intellectual honesty. Johnson recognized what he did not know. He lacked veterans' experience, had never faced enemy fire, possessed only theoretical understanding of tactics he had never executed under combat pressure. But he also recognized that experience could create blind spots as easily as insights, that veterans might be applying lessons learned in different aircraft to a platform that demanded different approaches, that conventional wisdom deserved questioning when evidence suggested alternatives. This balance between appropriate humility and intellectual courage characterized his entire approach to mastering the Thunderbolt. But Johnson's theories remained just theories until combat validated or disproved them. That validation would come through a series of increasingly intense engagements over occupied Europe, culminating in a mission over Berlin that would test every assumption about what the P-47 could and could not do. Before that crucible, however, Johnson needed to survive long enough to apply his developing understanding of tactical innovation against pilots who had been fighting this war since before he learned to fly. The transformation of the P-47 Thunderbolt from liability to asset represented more than just a single aircraft's redemption. It embodied fundamental principles about how innovation occurs in combat, how doctrine evolves under pressure, and how individual initiative can reshape institutional understanding. At its core, Johnson's approach to flying the Thunderbolt challenged the prevailing assumption that all fighters must excel at the same missions using similar tactics. American fighter doctrine in 1943 still reflected considerable influence from World War I's romantic notions of aerial combat. Individual pilots engaging in turning dogfights, victory determined by flying skill and aircraft maneuverability, combat as essentially a contest of individual prowess. The P-51 Mustang fit this doctrinal paradigm perfectly: sleek, agile, capable of matching or exceeding German fighters in traditional turning fights. The P-47 violated every aesthetic and performance expectation that doctrine presumed essential. It was ugly where the Mustang was beautiful, brutal where the Mustang was elegant, overwhelming where the Mustang was precise. Johnson recognized that the Thunderbolt demanded entirely new tactical thinking, what would later be called energy fighting, as distinct from traditional turning engagements. Energy fighting prioritized maintaining speed and altitude advantage over maneuverability, using diving attacks to convert potential energy into kinetic energy, refusing engagements that surrendered the attacker's initiative to the defender's turning ability. This approach leveraged exactly those characteristics that made the P-47 unsuitable for traditional dogfighting. Its weight maintained momentum in dives. Its powerful engine provided excellent acceleration in level flight at high altitude. Its structural strength allowed violent maneuvers that would tear apart lighter aircraft. The concept challenged pilots' self-image as much as their tactical training. Dogfighting allowed individual skill to determine outcomes. Better pilots won turning fights through superior stick and rudder ability, situational awareness, and aggressive flying. Energy fighting reduced individual skills' importance, while emphasizing disciplined execution of predefined tactical sequences. A pilot following energy fighting principles might break off attacks against vulnerable opponents simply because doing so maintained altitude advantage for future engagements. This violated the aggressive instincts that attracted men to fighter aviation in the first place. The theoretical foundations of energy fighting traced back to earlier aerial combat theorists, though few pilots in 1943 studied aviation history systematically. World War I had produced pilots who understood that altitude represented convertible advantage. Height could be traded for speed through diving attacks, and speed could be reconverted to altitude through climbing maneuvers. German ace Oswald Boelke had articulated principles that emphasized altitude advantage decades earlier, but post-war romanticism had buried these tactical fundamentals beneath narratives emphasizing individual heroism and turning dogfights. Johnson's willingness to embrace this counterintuitive approach stemmed partly from his relative inexperience. He lacked the internalized assumptions that veterans brought from thousands of hours dogfighting in lighter aircraft. Where experienced pilots saw the P-47's characteristics as deficiencies compared to idealized fighter performance, Johnson saw them as simply different attributes that suggested different applications. His analytical mindset, considered pedestrian compared to natural flying ability, proved perfectly suited to recognizing that optimal tactics varied depending on aircraft capabilities rather than conforming to universal principles. The P-47's legendary durability constituted another element that Johnson learned to incorporate into his tactical thinking. The aircraft's designer, Alexander Kartveli, had prioritized pilot survival through massive structural strength, armor protection, and redundant systems. The radial engine could absorb tremendous damage and continue running. The airframe could sustain hits that would destroy lighter fighters. The cockpit armor protected pilots from angles that left other aircraft vulnerable. This durability meant that mistakes proved less immediately fatal in the Thunderbolt than in other fighters. Kartveli's design philosophy reflected lessons from earlier conflicts where fragile fighters proved deadly to their own pilots as often as to enemies. He had studied reports from the Spanish Civil War where Soviet I-16 fighters demonstrated that radial engines survived damage better than inline engines, where armor protection proved worth its weight penalty, where redundant control systems allowed damaged aircraft to return home. These lessons informed every aspect of the P-47's design, though they contradicted prevailing American preferences for lightweight fighters that emphasized performance over protection. Johnson recognized that this survivability created tactical opportunities unavailable to pilots in frailer aircraft. A P-47 pilot could accept calculated risks that would be suicidal in a P-51, could press attacks slightly longer before breaking off, could absorb the occasional hit from defensive fire without immediately losing combat effectiveness. This durability acted as a multiplier for aggressive tactics, allowing pilots to exploit opportunities that more cautious approach would miss. But it required trusting the aircraft absolutely, believing in its strength enough to accept damage that would psychologically devastate pilots accustomed to fragile machines. The psychological aspect of flying the Thunderbolt deserved recognition as fundamental as any technical consideration. The aircraft demanded absolute confidence from its pilot. Hesitation in committing to a diving attack surrendered the speed advantage that made the tactic viable. Doubt about the airframe's strength when pulling out of high-speed dives led to premature recovery that wasted altitude advantage. Second-guessing whether to break off an engagement or press home an attack undermined the disciplined execution that energy fighting required. The P-47 punished uncertainty as ruthlessly as it rewarded commitment. This psychological requirement explained why some veteran pilots never adapted to the aircraft, despite superior flying skills and extensive combat experience. They had learned to read the feedback of lighter fighters, to sense through seat-of-the-pants flying when they approached performance limits, to trust instincts developed through thousands of hours in aircraft that communicated their status through subtle vibrations and handling changes. The Thunderbolt's massive stability and enormous performance margins provided less feedback, requiring pilots to trust instruments and predetermined tactical sequences rather than instinctive feel. Johnson's relative inexperience again proved advantageous. He had not developed the deep instinctive connection with lighter fighters that made veterans hesitant to trust the Thunderbolt's different handling characteristics. He learned to fly fighters in the P-47, developing his instincts around its specific attributes rather than adapting from different aircraft. His feel for combat flying developed simultaneously with his understanding of what the Thunderbolt could accomplish, creating integration between pilot and machine that veterans struggled to achieve. The evolution of external fuel tank technology intersected with these tactical developments in ways that would prove strategically decisive. Early P-47 variants could barely reach the German border before turning back, a limitation that seemed to confirm the aircraft's fundamental unsuitability for strategic escort. But as engineers developed better drop tanks and pilots learned to manage fuel more efficiently, the Thunderbolt's range extended deeper into occupied Europe. By late 1943, P-47s could reach targets in Western Germany, and by early 1944, they could penetrate to Berlin itself. This range extension transformed the tactical equation. The Luftwaffe's defensive strategy relied on harassing bomber formations during their long transit through occupied territory, using hit-and-run attacks that accumulated damage even when individual attacks failed to destroy bombers immediately. German fighters could land, refuel, and attack again as bomber streams progressed toward and then retreated from their targets. extended-range fighter escort, disrupted this strategy by forcing Luftwaffe fighters to engage American fighters rather than attacking bombers unopposed. Suddenly, the air war's arithmetic changed. German fighters faced attrition they could not sustain, while American pilots accumulated experience that made them progressively more dangerous. The fuel tank development itself represented remarkable engineering achievement. Early drop tanks leaked, failed to feed fuel reliably, or created aerodynamic problems that reduced aircraft performance. Engineers at Republic and various subcontractors experimented with different materials, construction techniques, and mounting systems until they developed tanks that reliably extended range without compromising combat capability. These improvements occurred incrementally through 1943 and into 1944, each refinement adding miles to the P-47's effective radius and deeper penetration into German-defended airspace. Johnson would ride this confluence of tactical innovation and technological development toward a confrontation that would validate his understanding of what the Thunderbolt could accomplish. But first, he needed to survive the brutal learning process that killed so many pilots before they mastered their craft. The skies over occupied Europe offered no gentle introduction to combat flying, no forgiveness for mistakes, no second chances for pilots who misjudged distance or timing or opponent capability. Every mission brought opportunities for the kind of fatal error that ended careers before they truly began. Johnson's combat career accelerated through the late spring and summer of 1943 as the 8th Air Force intensified its daylight bombing campaign. Each mission provided opportunities to test his evolving tactical theories against the reality of combat, to refine his understanding of what the P-47 could accomplish, to develop the instinctive reactions that separated survivors from casualties. His learning curve proved steep but sustainable. He made mistakes but survived them, encountered situations that challenged his assumptions but adapted rather than rigidly adhering to preconceptions. On June 26, 1943, Johnson experienced the validation that transformed theory into demonstrated capability. During a mission escorting bombers to attack targets in France, he engaged a Focke-Wulf Fu-190 using pure energy fighting principles, maintaining altitude advantage, diving to attack, refusing to turn with the opponent, using speed to dictate engagement parameters. The German pilot tried to force a turning fight, executing the kind of maneuvers that had defeated less disciplined P-47 pilots in previous encounters. Johnson refused the invitation, instead climbing back to altitude after his attack pass, positioning for another diving attack, systematically denying his opponent any tactical advantage. The engagement lasted minutes rather than the hours of romantic aviation mythology, but those minutes contained enough violence and terror and exhilaration to mark Johnson permanently. His 850 caliber machine guns converged on the FW-190 during his second pass, streams of armor-piercing and incendiary rounds walking across the German fighter's fuselage and wing route. The Focke-Wulf shuddered, rolled, began trailing smoke, then departed controlled flight and spiraled toward the ground. Johnson watched long enough to confirm the kill, then scanned for other threats, checked his fuel state, oriented himself to the bomber formation's position, and rejoined his flight. The entire sequence consuming seconds as training and instinct merged into automatic responses. This first confirmed victory validated not just Johnson's personal ability, but his entire tactical approach. He had defeated an experienced Luftwaffe pilot in an aircraft designed for exactly the kind of combat they had just concluded, doing so by fighting the Thunderbolt's fight rather than attempting to match the FW-190's strengths. Other pilots in the 56th Fighter Group noticed. Questions about Johnson's unconventional tactics shifted from skepticism to interest. Even veterans who remained unconvinced that a rookie understood things, they did not begin to consider whether the P-47 might indeed require different tactical approaches than they had assumed. The victory's psychological impact extended beyond Johnson himself. His wingman had observed the engagement, noting how Johnson's disciplined execution of energy fighting principles had systematically dismantled a capable opponent's attempts to force advantageous combat geometry. This wingman described the engagement during debriefing, providing detailed account that allowed other pilots to understand the tactical sequence rather than just the outcome. Squadron intelligence officers incorporated Johnson's approach into tactical bulletins distributed throughout the group. beginning the process by which individual innovation became institutional doctrine. But validation came with nearly fatal education just a week later. On July 5th, Johnson's P-47 absorbed damage that would have destroyed any lighter fighter and probably killed its pilot. During an engagement with multiple FW-190s, German pilots managed to position behind him, exactly the scenario energy fighting principles aim to prevent. The Focke-Wulfs opened fire at close range, their 20mm cannon and 13mm machine guns raking Johnson's Thunderbolt from engine cowling to tail. Rounds penetrated the cockpit. Fragments struck Johnson in multiple places. Instruments shattered, the canopy exploded. The aircraft shook so violently that Johnson momentarily lost control. Any lighter fighter would have disintegrated under such concentrated fire. The P-47 simply absorbed the punishment, its massive radial engine continuing to run despite multiple cannon strikes, its structure remaining intact despite holes large enough to climb through, its control surfaces responding despite severed cables and shredded surfaces. Johnson, bleeding from several wounds and fighting shock, managed to maintain enough control to reach friendly territory and execute a forced landing. He walked away from the wreckage with injuries that required weeks of recovery, but nothing permanently disabling. The damage assessment conducted by Republic technical representatives revealed the full extent of what the Thunderbolt had survived. 21 cannon and machine gun strikes had penetrated the airframe, severing hydraulic lines, destroying electrical systems, puncturing fuel tanks, and shredding control surfaces. 3 rounds had struck within inches of the cockpit area where Johnson sat, deflected by armor plate that saved his life. The engine had sustained direct cannon hits that destroyed cylinders and damaged the supercharger, yet continued running long enough to bring Johnson home. Engineers photographed the damage extensively, using it to validate design decisions and identify potential improvements for future production aircraft. This experience completed Johnson's education about the Thunderbolt's true nature. The aircraft had saved his life through pure toughness, surviving damage that would have killed him in any other fighter. When he returned to flying in August, he possessed not just tactical understanding, but visceral confidence in the aircraft's protective qualities. That confidence allowed him to fly more aggressively, to press attacks slightly longer, to accept risks that more cautious pilots avoided, advantages that accumulated into higher effectiveness over time. Through late summer and fall 1943, Johnson's victory total mounted steadily. Each combat encounter added refinement to his tactical understanding. He learned to read enemy formations for vulnerable positions, to recognize when Luftwaffe pilots were experienced veterans versus when they were struggling replacements, to judge which situations offered genuine opportunities versus which were traps baited by clever opponents. His situational awareness expanded from cockpit to formation to entire tactical situation, developing the macro understanding that separated good pilots from great ones. The progression of Johnson's victories revealed systematic application of principles rather than random success. His 2nd through 5th kills occurred during July and August, each following similar tactical patterns. Altitude advantage maintained through disciplined positioning, diving attacks that exploited the P-47's speed and firepower, refusal to engage in turning fights regardless of apparent opportunities, immediate return to altitude after each attack pass. German pilots repeatedly attempted to force turning engagements, and Johnson repeatedly refused, demonstrating discipline that many veteran pilots struggled to maintain when presented with seemingly vulnerable targets. By September 1943, Johnson had achieved 6 confirmed victories, qualifying as ace and earning recognition from 8th Air Force leadership, but he remained focused on refining tactical execution rather than accumulating personal achievements. He spent hours debriefing younger pilots, explaining energy fighting principles, demonstrating proper tactical sequences through classroom instruction and training flights. His ability to articulate what he did intuitively helped other pilots understand and apply principles they might otherwise have missed. This teaching aspect of his contribution proved as valuable as his personal combat success in transforming the 56th Fighter Group's collective effectiveness. The 56th Fighter Group's collective understanding evolved in parallel. Colonel Zemke incorporated energy fighting principles into the group's tactical doctrine, disseminating lessons learned through formal briefings and informal discussions. Other pilots began achieving success using Thunderbolt-optimized tactics, validating that Johnson's approach was replicable rather than dependent on individual genius. The P-47's reputation began shifting within the 8th Air Force as combat results demonstrated capability that early skeptics had dismissed as impossible. This tactical evolution occurred against intensifying strategic pressure. Through fall 1943, Luftwaffe resistance stiffened as German fighters concentrated against bomber formations, attacking targets deep inside the Reich. American loss rates climbed toward unsustainable levels, threatening the entire daylight precision bombing strategy that undergirded Allied air doctrine. The Schweinfurt raids in August and October demonstrated that unescorted bombers could not survive against determined fighter opposition, no matter how heavy their defensive armament. Extended-range fighter escort transformed from desirable to absolutely essential for strategic bombing survival. The strategic situation created pressure that accelerated tactical innovation. Bomber crews who had endured German fighter attacks without effective escort desperately wanted fighter protection throughout their missions, not just during portions where existing fighters had sufficient range. Fighter pilots recognized that their fundamental mission was protecting bombers rather than achieving personal victory totals, though those totals provided useful measures of combat effectiveness. This alignment between strategic necessity and tactical capability created conditions where innovations like energy fighting received rapid acceptance rather than facing bureaucratic resistance. The P-47's range improvements arrived just as this crisis peaked. With larger drop tanks and refined fuel management procedures, Thunderbolts could now escort bombers to targets throughout Western Germany and increasingly into central Germany. But Berlin remained beyond range. The German capital lay deep enough inside the Reich that no existing escort fighter could accompany bombers all the way to target and back. This range limitation provided the Luftwaffe a sanctuary where German fighters could assemble without harassment, then launch mass attacks against bomber formations as they approached or departed Berlin. Strategic planners understood that penetrating Berlin's defenses required escort fighters capable of reaching the German capital, engaging the Luftwaffe's accumulated strength, and protecting bombers during the most vulnerable phases of their mission. The question was whether the P-47, even with extended range modifications, could accomplish this mission, or whether planners needed to wait for longer-ranged alternatives like the P-51 Mustang to become available in sufficient numbers. The answer would emerge not from engineering studies or strategic calculations, but from combat demonstration, from pilots willing to push their aircraft to absolute limits to determine what might be possible rather than what seemed probable. Johnson would provide that demonstration, though not through planning or intention. Instead, combat circumstance would place him in exactly the situation that defined the P-47's potential: alone over Berlin, outnumbered by experienced opponents, facing tactical situations that would test every lesson he had learned about energy fighting, surrounded by enemies in an aircraft that conventional wisdom insisted could not accomplish what he was about to attempt. The mission that would define Robert Johnson's combat career and vindicate the P-47 Thunderbolt launched on March 6, 1944. 8th Air Force Headquarters designated this operation as a maximum effort. Every available bomber and fighter committed to striking Berlin in daylight, demonstrating Allied ability to attack the German capital with precision despite its formidable defenses. For bomber crews, this represented the kind of mission that tested courage and resolve. For fighter pilots, it offered opportunity to engage the Luftwaffe's concentrated strength under conditions that would determine whether escort fighters could truly protect bombers over targets this deep inside Germany. The 56th Fighter Group's role involved escorting bomber formations during the most dangerous phase, the approach to Berlin where German fighters traditionally concentrated their attacks. Johnson flew as part of a 4-ship flight, maintaining position in the formation's defensive structure while scanning constantly for enemy fighters. The outbound flight proceeded without major incident through France and into Germany, routine navigation punctuated by occasional sightings of distant contrails that might indicate enemy fighters observing the bomber stream. As the formation approached Berlin, the tactical situation deteriorated rapidly. German fighters appeared in groups rather than individually, climbing from below where radar had vectored them to intercept positions, positioning for coordinated attacks on the bomber boxes. Johnson's flight leader called out enemy fighters, initiating the tactical sequence they had practiced countless times: maintain formation integrity, protect the bombers, engage only when necessary to prevent attacks on the bombers rather than seeking individual victories. The initial contact involved approximately 24 Messerschmitt Bf-109s. Approaching from the bomber formation's vulnerable high rear quarter, the classic Luftwaffe attack geometry that placed German fighters in position to dive through bomber formations while minimizing exposure to defensive fire. Johnson's flight maneuvered to intercept, climbing to altitude advantage, then diving to disrupt the German attack before it reached the bombers. The P-47's superior diving speed and firepower scattered the initial attack, forcing German pilots to break off before reaching firing positions on the bombers. But combat rarely respects careful tactical plans. Within minutes of initial contact, Johnson's flight became separated from the main formation during violent maneuvering to intercept German fighters attacking their assigned bomber box. Suddenly, Johnson found himself alone, his flight leader and wingmen scattered by the chaos of multiple simultaneous engagements, his radio filled with overlapping calls that provided no useful information about friendly positions, his fuel state indicating that time over target was limited, regardless of tactical situation. Standard doctrine dictated that a lone fighter should break off, descend to lower altitude where fuel consumption decreased, and return to base rather than attempting to continue the mission solo. Johnson recognized the doctrinal prescription, but also understood the reality. Bombers still approached Berlin, German fighters still positioned to attack them, and every escort fighter that remained engaged delayed or prevented attacks on bombers that lacked any defense against determined fighter assault. He made the tactical decision that would define his legacy. He stayed. The choice reflected calculation rather than bravado. Johnson assessed his tactical situation systematically. Fuel sufficient for perhaps 20 minutes over target. At current altitude, ammunition load still substantial after brief initial engagement, aircraft systems operating normally, position relative to bomber stream maintainable through navigation by reference to distinctive Berlin landmarks visible below. Against these capabilities, he weighed the threats. Multiple German fighter formations operating in their home airspace, experienced pilots who knew this battlefield intimately, ground-based radar directing fighters to optimal intercept positions, the psychological challenge of fighting alone without mutual support from wingmen. What followed tested every aspect of Johnson's tactical understanding and the Thunderbolt's capabilities. German fighters recognized the lone P-47 as a target of opportunity. Isolated American fighters rarely survived encounters against multiple experienced opponents. They positioned for a coordinated attack designed to force Johnson into exactly the kind of turning fight that would neutralize the Thunderbolt's advantages. Multiple Messerschmitt Bf-109s approached from different angles, their pilots anticipating that Johnson would turn to meet one threat and present his vulnerable aspects to attacks from other directions. Johnson refused to cooperate. Instead of turning to meet the closest attacker, he pushed his throttle forward and dove slightly, trading altitude for speed while maintaining enough energy to climb back if necessary. The German pilots adjusted, following him down while trying to cut inside his turn radius and force close-range engagement. Johnson timed his response precisely. As the Bf-109s committed to their attack geometry, he pulled back sharply on the stick, using the P-47's powerful engine and the energy he had preserved to execute a climbing turn that brought him above and behind the German fighters rather than continuing the dive they had anticipated. This single maneuver demonstrated energy fighting's core principle, using three-dimensional maneuvering and energy conservation to dictate engagement geometry rather than accepting the opponent's preferred tactical situation. The German pilots suddenly found themselves in disadvantaged positions, having committed their energy to an attack profile that Johnson simply refused to fly. He rolled inverted, pulled through toward the nearest Bf-109, and fired a burst that forced the German pilot into defensive maneuvers, while Johnson continued through the engagement and climbed back to altitude. The technical execution of this sequence required absolute precision. At high altitude, where thin air reduced control surface effectiveness, any hesitation or over-control could bleed energy fatally. Johnson maintained exact control inputs throughout the maneuver, never exceeding the P-47's optimal angle of attack that would create drag, always preserving enough airspeed for the subsequent climb, constantly scanning for additional threats while executing violent maneuvers. Years of training compressed into seconds of execution, muscle memory and calculated responses merging into performance that appeared effortless but represented countless hours of practice. The engagement continued for what felt like hours, but actually consumed perhaps 10 minutes. Multiple attack runs by German fighters, defensive maneuvers that kept Johnson alive while preventing the Luftwaffe pilots from positioning effectively, occasional offensive opportunities that Johnson exploited when German pilots made positioning errors. His situational awareness expanded to encompass the entire tactical situation, fuel state declining toward emergency levels, ammunition expenditure limiting future engagement options, bomber formations continuing toward Berlin, with German fighters still attempting to penetrate their defensive boxes. During one particularly intense sequence, Johnson found himself between two groups of German fighters, 4 Bf-109s above and slightly ahead, 3 more climbing from below and behind. The geometry suggested coordinated attack, with the lead group intended to force Johnson into diving maneuver that would place him directly in front of the trailing group's guns. Johnson recognized the trap, understanding that conventional energy fighting response, diving away from the lead threat, would accomplish exactly what the German pilots intended. Instead, he executed a maneuver that violated energy fighting's usual prescriptions, but exploited the P-47's specific characteristics. He pulled into a climbing turn toward the lead group, accepting temporary energy loss to position his 850 caliber machine guns on the nearest Bf-109. The unexpected maneuver surprised the German pilots, who had anticipated defensive dive rather than aggressive turn. Johnson fired a long burst that struck the targeted Bf-109, then immediately rolled inverted and pulled through into dive that used gravity to recover the energy his climbing turn had consumed. The trailing group of Bf-109s fired at Johnson during his dive, their rounds passing close enough that he heard impacts even through the engine's roar. But the P-47's armor absorbed the hits, protecting Johnson while he accelerated past the German fighter's effective firing solution. He pulled out of the dive with airspeed, approaching the P-47's structural limits, converting speed into a climb that placed him once again in advantageous position above the engagement. This sequence, aggressive maneuver followed by defensive dive followed by energy recovery through climbing, demonstrated the flexibility that mastery of energy fighting principles provided. Johnson had violated strict energy conservation during his initial climbing turn because tactical geometry demanded it, but immediately recovered that energy through proper dive technique. Lesser pilots attempting the same maneuver without understanding its underlying principles would have found themselves slow and vulnerable. Johnson's complete integration of tactical theory and aircraft capabilities allowed him to improvise variations on energy fighting's themes without abandoning its fundamental principles. Johnson recognized he could not defeat multiple opponents outright, but he could deny them easy attacks on the bombers by forcing them to focus on him rather than the B-17s and B-24s, struggling through flak and fighter attacks toward their targets. Every minute he kept German fighters engaged represented bombers that survived attacks they otherwise would have faced. His mission transformed from survival to calculated sacrifice, spending his fuel and ammunition to buy time for the bombers regardless of whether he personally returned. The Luftwaffe pilots eventually recognized they were fighting an opponent who would not make the tactical errors they relied upon to achieve kills. Their initial confidence that a lone American fighter represented easy victory gave way to frustration as Johnson systematically denied them advantageous positions. Several German pilots broke off to seek easier targets, while others continued pressing attacks with increasing desperation that created mistakes Johnson could exploit. During the engagement's final phase, Johnson tracked a Bf-109 that had committed to a diving attack on the bomber formation below. The German pilot focused entirely on his target, apparently believing Johnson was occupied with other threats. Johnson dove after him, accepting the fuel expenditure this pursuit required, because preventing even a single attack on the bombers justified the cost. He closed rapidly, the P-47's diving speed advantage allowing him to overhaul the lighter Bf-109. At optimal range, Johnson opened fire, his rounds striking the German fighter's fuselage and wing route. The Bf-109 shuddered, rolled, and departed controlled flight, disappearing into clouds below. But the Thunderbolt refused to quit. Its massive engine continued delivering power despite the oxygen-thin air above 25,000 feet. Its airframe absorbed hits from German fire without failing. Its controls responded even as fatigue made Johnson's inputs progressively less precise. The aircraft seemed to understand what its pilot demanded, providing just enough performance margin to keep executing energy-fighting tactics even as fuel gauges approached empty and ammunition counters showed hundreds rather than thousands of rounds remaining. Eventually, the German fighters broke off, whether from their own fuel limitations, recognition that this particular opponent would not be easily defeated, or simply the chaos of multiple engagements occurring simultaneously. Johnson never knew. He found himself suddenly alone in empty sky, contrails dissipating, the only sound his laboring engine and his own ragged breathing. He checked his fuel gauges and calculated whether he had enough to reach friendly territory. The numbers suggested he should execute an immediate descent to lower altitude, where fuel consumption decreased, then fly directly toward England without deviating for any reason. The return flight tested his navigation skills and fuel management as thoroughly as the combat had tested his tactical ability. He flew alone, unable to contact other aircraft or ground controllers, navigating by dead reckoning across occupied territory where any forced landing meant capture or death. The P-47's fuel tanks ran dry just as the English coastline appeared ahead, the massive radial engine coughing once before Johnson switched to his final reserve tank. He crossed the coast at low altitude, identified an emergency airfield, and executed a landing with almost no fuel remaining. Ground crews who examined his aircraft afterward counted more than 20 hits from German fire, cannon strikes and machine gun rounds that had penetrated the airframe in multiple locations. In any lighter fighter, several of those hits would have proven immediately fatal. The Thunderbolt had simply absorbed the damage and continued flying, protecting its pilot through structural toughness that vindicated Republic's design philosophy. Johnson climbed out of the cockpit exhausted but alive, having demonstrated in the most demanding circumstances imaginable what the P-47 could accomplish when flown according to principles that leveraged its unique characteristics. News of the engagement spread rapidly through the 8th Air Force. A lone pilot over Berlin, outnumbered, surviving through superior tactics and aircraft durability. This narrative validated the Thunderbolt in ways that staff studies and engineering reports never could. Pilots who had dismissed the P-47 as unsuitable for combat began reconsidering their assumptions. Ground crews took renewed pride in maintaining an aircraft that proved it could bring pilots home from situations that would have killed them in other fighters. Strategic planners recognized that with proper tactics and sufficient range, the P-47 could indeed escort bombers throughout occupied Europe, including the most heavily defended targets. Johnson's experience over Berlin represented the culmination of a learning process that had begun more than a year earlier when he first encountered the Thunderbolt. He had progressed from rookie pilot to tactical innovator, not through natural genius, but through systematic study, disciplined application of principles, willingness to challenge conventional wisdom when evidence suggested alternatives, and ultimately the courage to trust his analysis when testing it meant risking his life. The aircraft had progressed from despised liability to proven asset through exactly the same process: systematic application rather than mystical transformation, leveraging inherent capabilities rather than attempting to overcome fundamental characteristics. Yet Johnson's vindication of the P-47 also highlighted broader principles about innovation and doctrine. Existing tactical frameworks often persist, not because they represent optimal solutions, but because they reflect institutional experience and individual training. Challenging those frameworks requires not just alternative ideas, but demonstrated proof under combat conditions. Johnson provided that proof, but only because he possessed both the analytical capability to recognize alternatives and the combat opportunity to demonstrate their validity. Many good ideas die because their proponents lack either the understanding to articulate them clearly or the circumstances to prove them definitively. The Thunderbolt's redemption also illustrated how technical characteristics interact with tactical application. The aircraft's designers had created a platform optimized for specific missions: high-altitude escort, diving attacks, energy fighting, but had not clearly communicated this optimization to the pilots who would fly it. Early P-47 pilots judged the aircraft against tactical expectations developed for fundamentally different machines, finding it wanting when evaluated against inappropriate standards. Johnson succeeded by recognizing that the aircraft demanded evaluation against its own optimized mission profile rather than universal fighter standards. This recognition required humility of a particular type, the willingness to accept that one's existing understanding might be incomplete or incorrect. Veterans who dismissed the P-47 often did so from extensive experience that made them confident in their judgments. Johnson's inexperience created space for different conclusions precisely because he lacked the confidence that comes from successful application of existing knowledge. Sometimes expertise blinds as much as it illuminates, creating certainty that prevents consideration of alternatives that less experienced observers might recognize. Robert Johnson's combat career continued through 1944 with increasing success as he applied the tactical principles his Berlin experience had validated. His final victory total reached 28 confirmed kills, making him one of the war's leading American aces and the second highest scoring P-47 pilot in the European theater. But numbers alone failed to capture his ultimate significance. Johnson transformed how the entire 8th Air Force understood fighter tactics, demonstrating that aircraft optimization for specific missions created opportunities that generalized fighter doctrine might miss. The impact of Johnson's tactical innovations extended far beyond his personal achievements. The 56th Fighter Group adopted energy fighting as primary doctrine, disseminating principles through training that transformed collective effectiveness. Other P-47 units throughout the 8th Air Force incorporated similar approaches after observing the 56th's combat success. By mid-1944, energy fighting had become standard tactical doctrine for P-47 operations, fundamentally changing how American fighter pilots engaged Luftwaffe opponents over occupied Europe. This doctrinal transformation occurred rapidly once combat results validated the approach. Fighter groups that had struggled with high loss rates and limited combat effectiveness suddenly achieved dramatically improved performance after adopting energy fighting principles. German pilots who had grown accustomed to outmaneuvering P-47s in turning fights found themselves consistently defeated by American fighters that refused to engage on German terms. The tactical revolution Johnson had initiated cascaded through the 8th Air Force's Fighter Command, changing operational outcomes across the entire theater. The P-47 Thunderbolt itself achieved redemption far beyond Johnson's individual contribution. The type served throughout the European and Pacific theaters, ultimately destroying more enemy aircraft than any other American fighter. Over 3,700 confirmed aerial victories, plus uncounted thousands more destroyed on the ground during strafing attacks. Republic Aviation produced more than 15,600 Thunderbolts, making it the most numerous American fighter of the war. The aircraft that veteran pilots initially despised became the workhorse of American fighter aviation, serving not despite its characteristics, but because of them, once pilots learned to leverage what it offered rather than lamenting what it lacked. The statistical record tells part of the story, but misses crucial context. Those 3,700 aerial victories represented not just destroyed aircraft, but validated tactical doctrine, not just individual pilot achievements, but collective learning that made American fighter aviation progressively more effective throughout the war. Each combat encounter taught lessons that refined understanding of energy fighting principles. Each debriefing added detail to tactical bulletins that disseminated knowledge throughout the force. Each veteran pilot trained newcomers who would apply and further develop the principles Johnson had pioneered. The Thunderbolt's versatility extended beyond air-to-air combat. Its robust construction and heavy armament made it exceptionally effective for ground attack missions, where it destroyed tanks, locomotives, trucks, and infrastructure throughout occupied Europe. The same durability that protected Johnson over Berlin allowed other pilots to press attacks against heavily defended ground targets, absorbing flak damage that would have destroyed lighter fighters. By war's end, P-47s had proven equally capable in air superiority and ground attack roles, demonstrating adaptability that specialized aircraft could not match. In the decades following the war, Johnson's experience entered military aviation's institutional knowledge as an example of tactical innovation under pressure. Fighter pilot training incorporated energy fighting principles as core doctrine rather than alternative approach, recognizing that different aircraft optimized for different missions required different tactical applications. The romantic notion that all fighters should excel at traditional dogfighting gave way to more nuanced understanding that specialized aircraft performing specialized missions could achieve effects that generalized platforms could not match. This doctrinal evolution influenced aircraft design philosophy for subsequent generations. Post-war American fighters like the F-86 Sabre incorporated lessons learned from P-47 operations, emphasizing energy fighting capabilities through powerful engines, excellent high-speed handling, and structural strength that allowed aggressive combat maneuvering. The F-4 Phantom II, developed decades later, reflected similar design priorities: speed and power over traditional maneuverability, weapon systems optimized for specific tactical employment, durability that maximized pilot survival in hostile environments. But perhaps the deepest lesson from Johnson's story involves the intersection of technology, doctrine, and human factors in military innovation. The P-47 represented advanced technology that initially failed because doctrine did not accommodate its characteristics. Johnson represented the human factor that recognized the disconnect between technology and doctrine, then developed tactical innovations that aligned them. His individual initiative, operating within institutional constraints, created the space for transformation that neither pure technology nor pure doctrine could achieve independently. Modern military aviation continues to grapple with similar challenges. Advanced aircraft with extraordinary capabilities sometimes underperform because tactics remain optimized for previous generations of technology. Pilots trained in specific doctrinal approaches sometimes struggle to adapt when new platforms demand different tactical applications. The tension between institutional knowledge and innovative adaptation that Johnson navigated in 1943 remains relevant today as air forces worldwide attempt to integrate stealth, network-centric warfare, and autonomous systems into operational doctrine developed for earlier eras. The contemporary F-35 Lightning II program illustrates these continuing challenges. Initial operational units struggled to develop tactics that leverage the aircraft's unique characteristics: sensor fusion, stealth, electronic warfare capabilities, because pilots and commanders applied doctrinal frameworks developed for fourth-generation fighters. Only after several years of operational experience did F-35 units develop tactical approaches that fully exploited the aircraft's capabilities, a process remarkably similar to the P-47's journey from rejected liability to invaluable asset. Johnson survived the war, returning to civilian life and eventually writing a memoir that chronicled his combat experiences. Thunderbolt, published in 1958, became essential reading for aviation enthusiasts and military historians, providing detailed first-hand account of what fighter combat actually entailed versus romanticized narratives that dominated popular culture. Johnson remained modest about his achievements throughout his life, consistently attributing success to the aircraft's capabilities and his squadron mates' support rather than personal genius. This humility reflected accurate understanding. He had not transformed the P-47 through mystical insight, but through systematic study and disciplined application of tactical principles that leveraged the aircraft's inherent characteristics. The combination of pilot and machine produced effects that neither could achieve independently, a synergy that represented the ideal toward which military aviation continually strives. Johnson understood that his role involved recognizing possibilities that the aircraft's design had created, then developing tactical methods that converted those possibilities into operational capabilities. His post-war career demonstrated the same analytical approach that had characterized his combat flying. He worked in aviation industry, applying combat experience to improving aircraft design and pilot training. He consulted with Republic Aviation on P-47 improvements, providing feedback that informed later variants incorporating lessons learned from combat operations. He participated in Air Force studies examining fighter tactics, ensuring that institutional knowledge captured the practical wisdom gained through actual combat, rather than just theoretical analysis. The Thunderbolt itself disappeared from frontline service soon after the war, as jet aircraft rendered propeller-driven fighters obsolete. But its influence persisted through tactical doctrine, design philosophy, and institutional memory. Republic Aviation's emphasis on pilot protection through structural toughness influenced subsequent fighter designs, recognizing that survivability constituted a combat multiplier as valuable as performance. Energy fighting principles Johnson helped develop became fundamental to fighter tactics, taught to student pilots decades after the P-47 left service. The F-47 Thunderbolt II, the A-10 Warthog's official designation, deliberately honored its World War II predecessor by emphasizing similar design priorities: pilot protection, weapons payload, and durability over speed and maneuverability. Though designed for ground attack rather than air superiority, the A-10 reflected the same philosophical approach that Alexander Kartveli had pioneered with the original Thunderbolt, building aircraft tough enough to survive hostile environments and bring pilots home despite damage that would destroy more lightly constructed platforms. Johnson's legacy extends beyond aviation into broader understanding of how innovation occurs within hierarchical military organizations. His experience demonstrated that institutional progress requires individuals willing to challenge conventional wisdom when evidence suggests alternatives, but also requires institutional structures open to incorporating innovations that emerge from operational experience rather than just top-down planning. The 8th Air Force's willingness to adopt energy-fighting principles, despite their contradiction of established doctrine, reflected organizational flexibility that many military bureaucracies lack. This organizational dimension deserves emphasis because technical innovation alone rarely transforms military effectiveness. History contains countless examples of superior technology failing to achieve expected results because organizations could not adapt doctrine to leverage new capabilities. Johnson succeeded not just because he understood energy-fighting principles, but because the 56th Fighter Group and 8th Air Force provided environments where tactical innovations could spread from individual practice to institutional doctrine. What began as a story about a despised aircraft and an inexperienced pilot ultimately revealed deeper truths about how military innovation occurs. Progress rarely arrives through revolutionary breakthroughs that sweep away all previous understanding. Instead, it emerges through incremental refinements where individuals recognize possibilities that existing frameworks overlook, test those possibilities under realistic conditions, and communicate results in ways that allow institutional adoption. Johnson's contribution was not inventing energy fighting or discovering the P-47's high-altitude advantage. Engineers understood these characteristics from the beginning. His contribution was demonstrating practically what others understood theoretically, proving through combat application that alternative tactical approaches could succeed where conventional doctrine failed. The Berlin mission represented the crystallization of this entire evolutionary process into a single combat engagement. Everything Johnson had learned about the Thunderbolt, every tactical principle he had developed through study and practice, every refinement he had absorbed from previous engagements, all converged in those minutes over Germany's capital when survival demanded perfect execution of imperfect theory. The aircraft responded as he had learned to expect, providing exactly the performance margins his tactics required, protecting him through durability that less robust fighters could not match, enabling him to accomplish what conventional wisdom insisted was impossible. Stories like Johnson's persist in military culture because they illustrate principles that transcend specific technologies or historical periods. The tension between innovation and tradition, the challenge of recognizing when existing doctrine requires modification, the courage to trust analysis when testing it carries mortal risk, the humility to learn from machines as well as mentors. These themes recur throughout military history, across all services and eras. Johnson's particular manifestation of these universal themes happened to involve a massive fighter over Berlin in 1944, but the underlying patterns appear whenever militaries attempt to adapt new capabilities to operational reality. For contemporary military professionals, Johnson's experience offers multiple lessons that remain applicable 8 decades after his Berlin mission. First, that technical capabilities require appropriate tactical application. Sophisticated technology without supporting doctrine often underperforms simpler systems used optimally. This lesson applies to contemporary debates about artificial intelligence, autonomous systems, and networked warfare, where technological capabilities frequently exceed doctrinal frameworks for their employment. Second, that innovation often emerges from unexpected sources. Johnson's inexperience created space for insights that veterans' expertise might have foreclosed. Modern militaries increasingly recognize that junior personnel operating new systems sometimes develop tactical innovations more quickly than senior leaders trained on previous technologies. Creating organizational cultures that allow bottom-up innovation while maintaining necessary command authority represents ongoing challenge that Johnson's experience illuminates. Third, that combat validation remains essential for institutional change. Without Johnson's demonstration over Berlin, energy fighting might have remained theoretical rather than becoming foundational doctrine. Contemporary militaries face similar challenges, integrating lessons from limited combat operations into broader institutional practice, particularly when those lessons challenge established assumptions or require expensive changes to training and equipment. Fourth, that individual initiative matters even within hierarchical military organizations. Johnson's willingness to challenge conventional wisdom created value that rigid adherence to existing practice would have prevented. Balancing military hierarchy's necessary discipline with space for individual initiative has challenged commanders throughout history and remains relevant today as technological change accelerates and operational environments grow more complex. The P-47 Thunderbolt and Robert Johnson achieved immortality not through perfection, but through perfect alignment of capabilities and application at the moment when both were most needed. The aircraft provided attributes that strategic circumstances demanded once tactical doctrine evolved to leverage them. The pilot provided the intellectual curiosity and practical courage to develop that doctrine under combat conditions. Their partnership demonstrated what becomes possible when technology, tactics, and human factors align. A demonstration that resonates decades later for anyone attempting to understand how military innovation actually occurs versus how organizational theory suggests it should occur. So when we ask what transforms a forgotten aircraft into a legend, the answer emerges from this story with unexpected clarity. It is not the machine itself, not the pilot in isolation, not even the combination of specific capabilities and specific circumstances. It is the recognition that problems often contain their own solutions once observers learn to see possibilities rather than limitations. Once doctrine adapts to leverage what exists rather than lamenting what is absent. Once individuals possess both the understanding to recognize alternatives and the courage to prove them under the harshest possible conditions. Johnson and his Thunderbolt over Berlin in 1944 embodied this recognition. A rookie who saw potential where veterans saw failure, an aircraft that succeeded through unconventional application of controversial capabilities, a mission that validated theory through survival and success. This combination rewrote assumptions about what was possible in the air war over Europe. The reverberations of that rewriting continue today in fighter tactics, aircraft design philosophy, military innovation doctrine, and organizational approaches to integrating new capabilities into operational practice. Sometimes the greatest victories are not the battles won but the minds changed, not the enemies defeated but the possibilities revealed. That was Robert Johnson's ultimate achievement and the P-47 Thunderbolt's lasting legacy. They demonstrated that excellence emerges not from conforming to existing standards, but from recognizing when circumstances demand new standards, not from accepting limitations, but from discovering capabilities that limitations had obscured. This lesson transcends its World War II context, offering insight into how innovation occurs across all domains where technology, doctrine, and human factors intersect to create possibilities that none of those elements could achieve independently.